Hi folks. Today we're talking about section 1-6, which is solving absolute value equations. Up until now we've been talking about absolute value functions on a graph. Today we're going to start talking about absolute value functions that are written as equations. So the essential question today is, how do we solve an absolute value equation? And our second essential question is going to be, how do we check our answers? Because you are going to be expected to check your answers. How do we check our answers? Okay. So our process to solve an absolute value equation, there are 6 steps, but they really aren't that big of a deal to write them all separately. I have them all listed separately right now because you're just now learning. The first step in the process to solve an absolute value equation is to isolate the absolute value. Isolate is a math word. It's also kind of like an everyday language word. But to isolate means to get by itself, to get alone, to get isolated. So isolate the absolute value. Step 2 is to make 2 equations. I'll show you how to do that in a second. Step 3 is to solve each equation. So if you've made 2 equations, you're going to have to solve both of them. Step 4, you're going to check your solutions by substituting your answers back into the original problem. And once you do that, that will allow you to identify any solutions that are extraneous. This is probably a new word for you, extraneous. Oops, there we go. Extraneous. Extraneous solutions are values that should be answers, but when you substitute them back into your original problem, they don't work out. So extraneous solutions are not really solutions because they are extraneous. So once you identify if you have any of those, then you can write the final solution set. So in example 1, the first step is to isolate the absolute value. Remember that the absolute value symbols are here and here. And that's the only thing that's on the left side of the equal sign right now. I don't have any extra stuff going on the left side of the equal sign. I just have the absolute values. So step 1, isolate the absolute value, done. Step 2, make 2 equations. Remember that the absolute value means the distance from 0. So whatever value is in that absolute value set of symbols, it could be positive, or it could be negative, but once you take the absolute value, you will end up with the positive answer. So what we're going to do is we're going to take this that's in here, we're going to drop the absolute value signs, we're going to make this side positive, so 2x plus 4, just kind of an implied positive over here, equals 4x. But then we're also going to have the possible solution where 2x plus 4 equals 4x, but with a negative. Because remember that you can have a positive or a negative inside of the absolute value symbols, and the answer will end up being positive. So we need to consider both options whenever we're solving to find the value of x. So step 2, make 2 equations, done. Step 3, solve each equation. Remember, when you solve an equation, you want to get the variables on one side of the equation, and you want the constants or the just numbers by themselves on the other side of the equation. So I notice there's an x on the left and an x on the right. I'm going to move this x to be over here using inverse operations, opposite operations. 2x minus 2x is 0, so it's gone. I still have the positive 4 on the left. And on the right side, if I combine my like terms, 4x's minus 2x's leaves me with 2 more x's. I still don't have x by itself. I still haven't solved this equation. The 2 and the x are touching, which means that's multiplication. To undo multiplication, the inverse operation is dividing. So I'm going to divide by 2 because 2 divided by 2 is 1x. And if I take 4 and I divide by 2, I get an answer. So I've gone and solved one equation. I want to do the same thing for the other equation, but I notice that I've got this negative out here. Now there is a trick that you can use. You can either distribute this, which I tend to not do. You can also imagine that this is a -1 and divide both sides by -1 to make this go away. So now you have 2x plus 4 on the left, and you have -4x on the right. Now the shortcut is just to take the negative from over here and put it over on the right side. So I want to combine my like terms. I have an x on each side of the equal sign, so I want to move this to be with this x. So I'm going to do inverse operations. 2x minus 2x is 0. I still have a plus 4. 4x minus 2 more x's is -6x. They're touching, so that's multiplication. The inverse operation is to divide by -6. I have that x equals -4/6, but 4 and 6 are both divisible by 2, so I can simplify that fraction to be -2/3. So now I have two answers that I need to check. X equals 2 and x equals -2/3. One is obviously much easier than the other, but the fraction is not difficult. So I've solved each equation. Now I want to go back and check my solutions by taking them and substituting them into my original problem right here. So my original problem was the absolute value of 2 times x. I'm leaving that open because I'm going to insert an x in a second. The absolute value of 2 times x plus 4, close the absolute value, and it equals 4 times x. Now I'm not sure if this is correct, so I'm putting a question mark. But what I want to check is I want to check the 2. So I'm going to insert this x value here and see what happens. So I use PEMDAS. Inside of my absolute value, I have multiplication and I have addition. I'm going to do the multiplication first. 2 times 2 is 4, and 4 plus 4 is 8. So the absolute value of 8 equals 4 times 2, which is 8. Is that true? Yes, that is true. So that means that 2 is a solution. It's not extraneous, because when I substitute it back into the problem, it actually works. So now I'm going to do the same thing with my other answer that I got. So my original problem here was the absolute value of 2 times x plus 4, close my absolute value, equals 4 times x. So I'm going to substitute my x value, -2/3 and -2/3. Okay, so remember that whenever you are multiplying a whole number like 2 with a fraction like -2/3, what you're really doing is you're multiplying the whole number in the numerator, because this is kind of like 2/1. So you're multiplying top times top, that's -4, and bottom times bottom, 1 times 3 is 3. When I add 4, I don't just want to add 4, I want to add something that equals 4, but it's got to have a denominator of 3. So the way that I get that is I multiply 4 times 3 and I get 12. 12/3, or 12 divided by 3, is equal to the 4. But now I have common denominators and I'll be able to add those terms. Same idea on the right side that we had with this multiplication over here. We're going to multiply the 4 times the -2 and get -8. And we're going to keep the 3 on the bottom. So now the last thing that we have to do is this math here. So I'm going to add my fractions, meaning I'm going to add the numerators and keep the denominator. Negative 4 plus 12 is 8. I'm going to divide by 3, take the absolute value, and it's supposed to be equal to negative 8 thirds. Is it? The answer is no, it is not. You can't take the absolute value of something and get a negative answer. So that is an extraneous solution. X equals this negative 2 thirds doesn't work out. So that is an extraneous solution. However, the 2 was a solution, so it's in my solution set. Remember when we write set notation? We open with a brace, we put our content, and then we close with the brace. So when I talk about the solution set, you're putting that number of solutions in braces. Okay, so let's move to the next one. The next one, in example 2, and if you choose to work this a little bit slower, that's totally fine. I'm not going to work it incredibly slow because I don't want this video to be 30 minutes long. So I'm going to work it a little bit faster. For example 2, I don't want this extra constant over here, so I'm going to move it over. So I'm going to subtract 4 from both sides. I still have negative 9 times the absolute value of 4y plus 1. And negative 23 minus 4 more is negative 27. I'm trying to isolate the absolute value, so this negative 9 that's being multiplied is in the way. If I want to break the multiplication, I have to divide by negative 9. I have the absolute value of 4y plus 1 is equal to 3. So now my absolute value is isolated. Step 2 is to split into 2 equations. First equation, 4y plus 1 equals 3, so positive. Second equation, negative 4y plus 1 equals 3, which I can then convert to 4y plus 1 equals negative 3. Remember our little trick on the last problem where we were able to move this negative over to the other side. So next step is to solve my 2 equations. I'm going to move my constant over here with this constant. I have 4y equals 3 minus 1, which is 2. And I'm going to undo this multiplication by dividing. So I have y equals 2 fourths, but 2 and 4 are both divisible by 2, so I can simplify that fraction. So I need to check this to see if it is a solution. Next thing that I want is the solution to this equation. So I'm going to move this constant over with the other one by subtracting 1. I have 4y equals negative 3 minus 1 more. That's negative 4. And when I break that multiplication, I have y equals negative 1. So that is the other number that I'm going to check to see if it's a solution. So the next step is to take my answers and substitute them into the original problem to see if they're solutions or if they are extraneous solutions. So I'm going to write my problem. I had 4 minus 9 times the absolute value of 4 times a y value. I'm keeping that open. Plus 1, close the absolute value, should equal negative 23, but I don't know if it does, so we're going to see. So I'm going to take 1/2 and I'm going to substitute it here. Oh, nope, that's it. Okay. So I have 4 minus 9 times the absolute value of 4 times 1/2. So 4 times 1/2 is 4 times 1, which is 4, over 2. 4 divided by 2 is 2, plus 1. And it's supposed to equal negative 23. Okay. Well, what is 2 plus 1? I'm still in the kind of grouping part, or almost parentheses part of PEMDAS. I'm still working on this. So 2 plus 1 is 3, and the absolute value of 3 is just 3. The next part of PEMDAS is not subtraction, it's multiplication. So I'm going to multiply -9 and 3 together, and I'm going to get -27. And when I subtract 4 minus 27, I get -23. So it turns out that y equals 1/2 is actually a solution to this absolute value equation. Now I'm going to try my next one. So I'm going to rewrite my original equation. 4 minus 9 times the absolute value of 4 times y plus 1 equals -23. So I'm going to go ahead and substitute -1 here. My parentheses, kind of my absolute value grouping here. 4 times -1 is -4, and -4 plus 1 is -3. So 4 minus 9 times the absolute value of -3 equals -23. What is the absolute value of -3? Well, it's just 3. And I notice that this line looks a whole lot like this line. So I'm going to end up getting the same answer. Does this solution work out? Yes, it does. So both of these work out. I have none here, so no extraneous solutions, but my solution set, open the brace, my solution set has 2 answers in it. And I'm going to write them from least to greatest. So I'm going to start with -1, and I'm going to finish with 1/2 and close my brace. All right, so I'm going to move to example 3, and I'd like for you to pause the video and try example 3 on your own. So I just want to check with you step by step. Step 1 is to isolate the absolute value, so you have to move the +8. And then step 2 is to separate into 2 separate equations. And I want to make sure that when you make your negative equation here and then you move it to the other side, the 2 is already negative, so if you apply another negative, you get a positive. So the next step is to solve both equations and substitute them back in to check. So I'll let you do that. Pause your video. Remember that you want to substitute the 2 values that you get into the original function. So I went ahead and I wrote the original functions out, and I need to substitute my -3, and I also need to substitute my 1, and solve and see if I get extraneous solutions or actual solutions. Continue and let me know what you get. So I realized as I paused my video that I told you to let me know what you get, and you can't let me know what you get unless you just want to remind text me, which of course you can. But when I substituted my x values in, I realized that -2, if I take the absolute value, is 2. And when I add 8, I'm never going to get 6. Same situation here. So it turns out that both of those answers are extraneous. So x equals -3 and x equals 1 are extraneous. When you substitute them, they don't work. So are there any solutions that work? No. So we say that this is no solution. This has no solution. Okay, so we've got 2 more to do. This one looks a little crazy, but it's really not too bad. So on this one, the first thing I want to do is move away the -9, that constant that's hanging out on the left side. So I'm going to do the opposite of -9. I'm going to add 9. And I have the absolute value of x minus 5 divided by 4 equals -2 plus 9. So that would be 7. And I do not want this. This is not the absolute value isolated. It's the absolute value being divided by 4. So what is the opposite operation of dividing by 4? The inverse operation is multiplying by 4. And what you do on one side, you do to the other. So now I have an isolated absolute value side of the equation. So go ahead and pause the video. I am going to work out the rest of this problem by the time that you click back. All right, folks, so even though we got some kind of crazy values, we got x equals 33 and x equals negative 23, we find that both of them work, so there are no extraneous solutions. We have two solutions here in our set, so open your brace, write the smaller one first, which is negative 23, because it's negative, and 33 follows. And finally, we have example 5. Example 5, the absolute value is already isolated. There's no extra number here or a plus or minus a constant here. So I'm going to go right to writing my two equations. Now, when I write my equation that is negative, I am going to write negative in parentheses 4x minus 1. Because if I were just to move this negative over here, well, then I would just be applying it to the 2x and not to the 9. If I do move the negative over here, I need to apply it to both of these terms. So if I move it over, instead of 2x, I now have negative 2x. Instead of plus 9, I now have minus 9. So these are my two equations that I want to solve. And I'm going to just go ahead and finish with this one. I'm going to move my x's together. So now no more x's here, but 6 of the x's here. And I'm going to move my constants together. So no more constant here, but now I have negative 9 plus 1, which is negative 8. And when I divide, I can simplify. Both negative 8 and 6 are divisible by 2, so I have negative 4/3. That's one of the answers that I want to check. Now on the other side, I want to combine my x's. So these will cancel and become 0. I have 2x minus 1 equals 9. I want to combine my constants, so I'm going to move this over. 2x equals 10. And you can see if you divide by 2 on both sides, you get x equals 5, which is a much nicer answer, something that we're more comfortable with. So I substitute my x value of 5 into the original function. 4 times 5 is 20. 20 minus 1 is 19. And the absolute value of 19 is just 19. On the right side, 2 times 5 is 10, and 10 plus 9 is also 19. So this is a solution. Now, when I substitute negative 4/3 in place of x, remember that I'm multiplying the 4 and the 2 by the negative 4 that's in the numerator, not the denominator. The denominator is staying. So I have the absolute value of 4 times negative 4, that's negative 16 over 3, minus, how would I write 1 as something with the denominator of 3? What divided by 3 is 1? That would be 3. And then on the right side, 2 times negative 4 is negative 8 over 3, plus I need to write 9 as something over 3. So it's 9 times 3. 27. So in my absolute value signs, I have some subtraction here. I'm only going to do that on the numerator. I'm still going to have a denominator of 3. That's the way you add or subtract fractions. So negative 16 minus 3 is negative 19, still over 3. And then here I have a common denominator, so I'm going to add the numerators. Negative 8 plus 27 is 19, and it's still over 3. So is the absolute value of negative 19/3 equal to positive 19/3? Yes, it is. So I have no extraneous solutions, and my solution set, I start out with the smaller one, which is the negative one, is negative 4/3 and 5.